first section in Crash Course in Crash Physics is kinematics. Kinematics is the study of motion of objects using words, equations, graphs, and diagrams and numbers. Kinematics is a study aimed at explaining the motion of objects. Now let's talk about two key factors or concepts of kinematics. First, we have velocity. Velocity is a vector. Vectors are important because it makes a velocity, it gives it direction. Another key element or concept in kinematics is distance. Distance is the area traveled. In this video, we have a short distance and a high speed, which leads to more damage. In this clip, we're going to talk about velocity. Velocity is a distance covered by the object over a certain amount of time. The faster the velocity is, the more damage that can happen. As you can see in this video, we're showing you different velocities, and every time we have a different velocity, you can see the damage that it causes the car. The higher the velocity, the faster the velocity, the more damage caused to the car, to the person, to the object. Another key concept in kinematics is acceleration. Acceleration is velocity over time. You can say that if you have constant velocity, you have zero acceleration. Acceleration and velocity are both vectors, but they do not always match in their direction. And when this happens, direction changes. But if the speed nor direction are changing, then you have zero acceleration, which means that you're moving in a straight line, which means that you do not speed up or slow down. So in the previous clips that we've seen, we could say that we have zero acceleration because we're moving in constant velocity. Now we move on to dynamics, and dynamics is the study of why things move. Let's keep this video going by watching this next clip. Newton's first law of motion is also known as the law of inertia. Inertia is any tendency to resist a change in motion. Newton's first law states any object at rest will remain at rest as long as no net force acts on it. The second part of the law states that any object moving with constant velocity continues to move with the same speed and in the same direction as long as no net force acts on it. Now let's apply it to this video clip. As you can see, the car and the dummy are moving at the same speed. Therefore, when the car crashes and stops, the dummy continues to move forward because it is moving and it wants to continue to move until an external force acts on it. Moreover, let's talk about Newton's second law. Newton's second law is F equals ma, which is force is equal to mass times acceleration. This formula is used to explain how a force changes an object's motion. A force is a push or pull that can accelerate or decelerate an object's motion. A force is the cause that creates an effect. It is something that adds or removes energy of motion. In this case, the force acting on the object is the wall. Let's find out how much force is exerted on the driver and the car with the measurements given in the video. Here's an example provided below in the picture. This is a bonus concept. Another concept is a frame of reference. Depending on how you look at the object, it can or cannot be moving. Furthermore, we have Newton's third law of motion. Newton's third law of motion states that for every action force acting on an object, there is a reaction force acting on a different object. It also states that the action-reaction forces are equal in magnitude and opposite in direction. As you can see in this clip, the force experienced by both objects were opposite in direction and equal in magnitude, which means that the amount of destruction is the same on both objects because they both experience the same force. Now we move on to energetics. Kinetic energy is the energy of motion. An object that has motion, whether it's vertical or horizontal motion, has kinetic energy. This object is in motion, therefore it has kinetic energy. Work is a product of force and the distance moved by the force. W is equal to Fd. Work is done when a force is applied to an object and the object moves in the direction of the applied force. In this case, both cars' total work done is 0. This is because the force, which is gravity, has a downward direction, and the two cars' direction is either to the right or to the left, but not downward. Therefore, the work done is 0 because in order for work to be done, you need to be moving in the same direction as the applied force. Power is the amount of work done in a given amount of time. P is equal to W over T. The faster work is done, the greater the power. For example, suppose it takes a certain amount of work to accelerate a car from 0 to 40 miles per hour. If the average power provided by the engine is P, then the amount of time required to reach 40 miles per hour is equal to T is equal to W over P. We can apply this to the video clip because we can say that the power of a car is a measure of how fast it can go fast. Momentum. Momentum is mass in motion. In the video clip that you're watching, you're going to see the difference in impact with and without a seatbelt and airbag. Increasing the time of impact decreases the force. We can apply this to the airbags and the seatbelt of the car. The airbags and the seatbelt inside the car increases the time of impact, therefore reducing the force and the extent of injury to the head and the body. As you can see, the impact is much bigger without a seatbelt and the airbag. An inelastic collision is one in which the kinetic energy changes as a result of the collision. This means that the final kinetic energy is not the same as the initial kinetic energy. In a typical inelastic collision, part of the initial kinetic energy is converted to sound, heat, and deformation. In this clip, the collision is inelastic because it makes a large impact sound and it bounces back deformed in the crumple zone. Another concept is only an external force can change a system's momentum. Internal forces have no effect on a system's momentum. Therefore, in this case, if a seat inside the car pushes you or lunges you forward, that does not affect the overall momentum of the system. But if an object outside of the system, such as another car, crashes into your car after you crashed into the object, then that does affect the overall momentum of the system.